today's session speaker, Dr. Jaydeep Mukherjee. He's joining all the way from Florida, USA. And as you have been hearing our conversation, that part of US has been massively hit by a very big hurricane, and in fact we're not sure whether going to have this talk today. We were thinking to postpone it, but thanks to Dr. Jaydeep sir, and thanks to that hurricane did not hit his part that massively, and there he is today online giving for the talk for the World Space Week 2022. I am Dr. Chintamani Pai, co-founder Space Geeks. I welcome you all for World Space Week 2022. I hope that you are going to enjoy all these talks, and we are very fortunate to have Dr. Jaydeep Mukherjee sir for today's very first online talk, where he's going to take us virtually on the moon, and he's going to talk about humanity's return to the moon, basically the NASA's Artemis moon mission. And I'm sure all students, professionals, and space enthusiasts, whoever is watching from Zoom, and we are also live on Facebook, I'm sure all of you must be enjoying this. If you are not live on Facebook,
hello.
Very fortunate. Thank you for joining. And as of you UN article, which actually on 6 December 19 recently it came into the picture, and where it puts emphasis why we have to celebrate World Space Week, because all of us, we know that most of the technologies around us, they actually have emerged from technology. Whatever money, the huge money being invested in space technology over the years, those technologies become a regular part of our lives. And to celebrate that, to remember what is all space technology about, to create awareness, we celebrate World Space Week. And here we are celebrating World Space Week 2022. With that, I invite Umesh Rastagi, who is director of Nehru Science Center, one of the largest science center in India, which comes under Government of India, to officially invite today's speaker, Dr. Jaydeep Mukherjee.
Okay. Should I start now?
Yes, sir.
Yeah. Am I audible, Chintamani?
Yes. Yes, sir. You're audible.
Okay. Okay. Thank you. And let me extend a very warm welcome to all our audience here, and a very special welcome to Dr. Jaydeep Mukherjee. As I mentioned that I had the opportunity to listen him at Nehru Planetarium in the past, and today we are fortunate that he is with us. In fact, I was going through that World Space Week celebration, their objectives, and there are many things which they have mentioned. It was it was making me to remember that when we had this seminar on Chandrayaan, to create public awareness, to give answers to many of the questions which people are having about space, whether we should go. Even, in fact, just half an hour back, there was a panel discussion in our auditorium. There also, again, the same question was asked, whether we need to go, how it will be benefited. So I think there is a lack of awareness about space science among young students, and even in some parents, they were asking certain questions about research which is going on in astronomy or space. In fact, ISRO has definitely established the kind of space science benefit we are having now. In fact, it started maybe from the site experiment itself, peaceful use. And the Space Week in October, there are two major events which has basically made UN to announce this as Space Week from 4th October to 10th October, though we have started from the first itself now. The 4th October 1957, which was Sputnik launch, first man-made Earth satellite. And then it started a new era, I should say, a new competition, new science and technology competition among USSR and European countries and America. And then the kind of race started. In fact, there is a lot of space spin-off. So after 10 years, a treaty was signed that we'll have the peaceful use of space applications, space technology and all that. So that's how we are celebrating. We at Science Center, we have a wonderful gallery also on aviation and space, which talks about many aspects of space, how, why we need to go, how we go, what are the basic principle of flights in that, what makes it to fly, controls, where the space starts, what are the things you can design your rocket, or many of the things are there in the gallery. How, and ISRO has also supported in that many things on that. So without taking much time, let me introduce Professor Jaydeep Mukherjee. Read out the information about him for the information of our audience. Dr. Jaydeep Mukherjee is the director of NASA Florida Space Grant Consortium, association of 17 public and private Florida universities and colleges, which led by the University of Central Florida and administered by the Florida Space Institute. The consortium also includes all of Florida's community, college, as well as Astronaut Memorial Foundation, Space Florida, Kennedy Space Science Center, Space Center, and Orlando Science Center, FSGC, which is short form for this, supports the expansion and diversification of Florida's space industry through by providing grant. In fact, Professor Mukherjee was also the administrator of NASA Florida Space Grant Consortium before at the University of Florida, and later the director of NASA FSGC at the University of Central Florida, located at Kennedy Space Center. He was also the director of Florida Space Institute from 2006 to 2011. Then he served as chair of the Southeast Regional Space Grant, comprising of 10 Southeast states from 2016 to 2014. Was also member of the board of directors of National Space Grant Foundation from 2006 to 2008, and then from 2012 to 2013 as well. Currently, he's serving on the board of directors of National Space Grant Alliance and is a member of a commercial space operation advisory panel at Embry-Riddle Aeronautical University. In 2011, the National Education Society of India presented him with National Eminence Award. In 2003, he was member of Radio Joe team that received the Group Achievement Award from NASA Goddard Space Flight Center for excellence in outreach. In fact, he is very active. We have listened him many times. So as outreach programs are concerned, whenever he comes to India, he made it a point to deliver and interact with young children, because that's the how we can motivate them and they come to know about the opportunities in space science in this field. In 1993, he was also awarded the Carrick Prize by the Astronomy Department at University of Florida for the commitment to the education of the public and to their understanding of astronomy. He has published one book also titled Close Binary Stars, a pictorial atlas, along with the co-authors Dr. Robert Wilson and Dr. Doug Terrell. His main interest is in close binary stars and STEM education, which is a buzzword. We always talk about science, technology, engineering, mathematics. His research interest includes synthesis of observable quantities for interacting binaries, understanding binary star mass transfer, mass loss, and formation of particularly interesting or unusual close binary stars. Dr. Mukherjee's personal interest includes following the sports of cricket worldwide, and he was an avid cricket. Maybe when next time he will come, sir, we had the opportunity when Mr. Kennedy was director, 3 cricket exhibitions. So when you will be coming next time to Mumbai, we'll offer you all the 3 books, and I am sure you would love it because you are very much interested in cricket as well.
Thank you.
Yeah, he was an avid cricket and tennis player himself also during his college and university days. So he's married to, okay. I think with this brief introduction, I will request Professor Jaydeep Mukherjee to take over, welcoming you once again. Sir, over to you. to start your deliberation.
Okay. Thank you very much. It's always, I don't know, most of the audiences from Mumbai or not, but I grew up in Mumbai and I went to college in Mumbai. And my first experience with astronomy was at the Nehru Planetarium when Dr. Venkatavardhan was the director. So I always love to come back and talk to students in India. But I wanted to talk to you today about the Artemis mission, NASA's mission to the moon, to show you how difficult it is in terms of engineering, in terms of politics, in terms of funds required to do this whole program. And before I do that, I understand today is International Observe the Moon Day or Moon Night. So it's a good day to have this talk. People talked about why we want to go spend money on outer space. So for my talk, I'm just going to talk briefly about why we explore space, then talk about the moon, because it doesn't make sense to talk about why we want to go to the moon unless we know something about the moon. I'll talk about how the moon was formed and about water on the moon, because that's the most important thing. If we can figure out where we have water on the moon, then we can have our settlements, our bases near those areas. And then finally, I'll talk about the NASA's Artemis program itself. What is it? How are we going to go there? Where are we going? And I won't have time in the end, but I think there's problems with moon dust. It's very important. And in our institute, the Florida Space Institute, we're doing a lot of research on that. Maybe that's another talk that I can provide, give more details on the work going on to understand the problems landing on the moon, having settlements on the moon, and so on. I always like to start with this, and of course, this is for people who love space. You already know this, but this is a way to just show you how insignificant we are. Okay, so I say we are in a we are in a 4.5 billion year old spaceship, and the spaceship we call Earth. It's self-sufficient. It's organic. It's made up of mostly carbon molecules. Most of us are made up of carbon, and it's very complex. We are orbiting a power source that we call the sun. There are more than 200 billion more power sources in a group, which we call the Milky Way galaxy. There are about 40 such galaxies in a neighborhood. And if you go on to look at the whole universe, there are more than 200 billion such galaxies in a universe. So what we want to say is, welcome to life. It's more exciting when you think of it in a larger scale. Gives you an idea how insignificant we are. We are a small blob orbiting a very average star in one of the corners of a galaxy, which is about one of the 200 billion galaxies in our universe. Now, and also there are talks, there are hypotheses of having multi-universes. And it goes on and on. It's very interesting. So why do we explore? So there are two types of exploration. One is because we do not know what we find, and I'll know it when we see it. So example, when you go and travel to other planets, mostly robotic, in some cases, you do not know what's going to be there. Like when we went to Pluto, we learned so many new things. So we explore it because we want to find out something new. Or we want to go and find out to test our hypothesis. So we think that, for example, if you take one of the moons of Jupiter called Europa, just 2 days ago, the Juno spacecraft sent us more pictures of Europa. And we think that this Europa has an water ocean underneath this crust of ice. So if there's a way that we can go through these cracks in the ice and look at what's in the water underneath, we might find some life, bacterial life form. We don't know that. So that's what we do. So that's what we explore. And again, why are we exploring space? And this is very important. Well, one thing is to protect and understand the world. We were talking about climate change. We're talking about all these hurricanes. with all the satellites looking down on the Earth, we get a better idea of how the oceans are changing, temperatures are changing, so we can protect and understand the world. Inspiration and exploration, this is where you come in. These are all the students in school and colleges. You need to be inspired, you need to be motivated. And I know most of you are motivated. That's why you are listening to a talk late, Sunday or Saturday evening. That's great. New technology, people tend to forget that as a result of exploration, new technologies are being developed. I mean, what I see in India right now, I see all the small companies coming up which are contributing to the to ISRO, whether it's for building rockets or spacecrafts. That was not the case before. So whenever you try to do and when you try to explore, whether it's in India or the US or China or anywhere else, new technologies develop, and that's actually translated to the rest of humanity in terms of new products. Answering unknown questions, that is a basic thing that we have for humanity. We are always curious. We want to answer some of the unknown questions, and this is the way to do it. International collaboration, these days you cannot do any good space activity without collaborating with other countries. It's tough to do that. Then long-term survival. For example, a few days ago, NASA deliberately crashed a small spacecraft on an asteroid just to see what will happen to the orbit of the asteroid. And in the future, if you see an asteroid coming towards the Earth, one of the ways we can do is to deflect that by just crashing into that asteroid and changing this path by a very small amount, and that might make it miss the Earth. So long-term survival, we need to do that. We need to do. If you try to see how much funds we spend, whether it's in India, whether it's in the US, it's negligible. It's negligible compared to the returns that we get from that. And I'm going to give you just some quick views of benefits of space exploration. This is more of NASA-centric, what's going on in the US, but starting from Velcro, advances in heart pump, GPS, digital cell phone technology, radiation lenses, Polaroid lenses, diapers, and so on. These are all a result of space technology. Look at this slide, and there are so many things that are being done in the world as a result of technology being developed from space exploration, whether it's a phone in your car, or whether it's climate change prediction, navigation, communication, solar power, in ambulances, and so on and on. I can take a whole lecture and talk about that. But tech transfer is a big thing in the US. NASA has transferred this technology to small companies. And I know it's also happening in India, with ISRO is transferring. Aditri, I'll answer your question in the end, if you don't mind. Okay? I'll remember you. I'll answer your questions in the end. So these are the surfaces that have been visited by humankind and rovers. The only place that we have landed is the moon. And yet you have a big section of the population who believe you haven't been to the moon. But you can't argue with them. As you can't argue with people who say that the Earth is flat. But we have been there, we have been to the moon, and then robotic landings on Venus, on Mars, on Shoemaker comet, on Titan. Titan is one of the moons of Saturn, and it's a very exciting moon, I think, because on that moon you have methane in 3 different forms: solid, liquid, and gas. There are liquid lakes of methane, and methane is nothing but carbon and hydrogen molecule atoms. And as you know, we are based on carbon atoms. So if there is so much methane in this liquid lakes, there's a chances there might be some kind of life form in there. I'm not talking about big, huge creatures, but maybe some kind of life form. So one of the plans that NASA has, is not yet approved, is to drop a submarine into one of these lakes to see what's going on. And maybe one of you guys, your students in school and colleges, will come up with a plan. We have landed on an asteroid, on a comet, and then, as you see, recently on Bennu, an asteroid close to the Earth. So we have landed on a number of surfaces. We have explored a number of planets in our solar system, and I don't want to go through this, but it just shows you that, of course, we have more satellites on the moon than other places because it's close by, but we have gone all the way to Jupiter, Saturn, Uranus, Neptune, Pluto, a lot of satellites around Mars, including India's satellite, and so on, even the sun. So we have explored a lot over the last few years. But when you talk about future of exploration of the next 10, 15 years, it's either we are going to be what is called low Earth orbit, where we have the space station, or we go to the moon, and then by the 2030s, we go to Mars and maybe some asteroids. Those are our future targets in the next 10 to 20 years. And when I say ours, I mean the whole world, not just NASA, not just ISRO, but the whole world. So I gave you an idea why we're exploring. And as I said, I'll give a whole talk on that, why we need to explore. We are not spending a lot of money. As you might have heard that the MOM mission is less than what you spend on crackers, fireworks in Diwali. Some of the missions at NASA is less expensive than a Hollywood movie. So I don't think we are spending a lot of money. And on a lot of the funds that we spend on space exploration benefits mankind on Earth. You need to remember that. So let's talk of the moon. This is just a snapshot of where the moon is in the sky at 9 a.m. today. That's about an hour ago. There's this lunar reconnaissance orbiter orbiting the moon. This is taken from a NASA software called NASA Eyes. You can, of course, go to that software. It's on the web, and you can see where everything is in the solar system. But this is some of the. Sorry, let's go ahead. This is some of the missions, Apollo missions that have landed on the moon. As you see, Apollo 11, 16, 17, 15, and then these are some of the also robotic missions on the moon from the Russians. Mostly the Russians and the Chinese over here, and so on. So we have landed a number of probes on the moon. We also have landed humans on the moon, as you can see in the slide. These are all the people who have traveled to the moon. Apollo 8 did not land on the moon, but they orbited the moon. And here you see like Apollo 11, Armstrong and Aldrin, they landed while Collins orbited the moon and so on. Aldrin actually lives about 30 miles south of where we are. He has an Aldrin Foundation and so on. I work with his son on space entrepreneurship projects. So we have landed on the moon a number of times. This gives you an idea of our size, moon size to scale with the Earth. So as you see, our moon is less than about 1/3 times the size of the Earth. But look at the size of the moon compared to the moons of other planets. And apart from the moons of Jupiter, the 4 inner moons, and Titan, the Earth's moon is pretty big. So here's one thing. This is my pet peeve. I don't really think we need to memorize numbers too much. Some of them, yes, we need to. But there's no need to remember what is the diameter of the Earth, maybe we should know. But what I look at is a relation, okay? So for example, the Earth's diameter is 12,000 kilometers. The moon is about 3,400. I want to remember, I would say, oh, the moon is about 27% of the Earth. So if I know the properties of the Earth itself, and if I know the relation, I can approximately know the actual values of the properties of the moon. I hate memorizing numbers. When I grew up as a student in India, I was forced to memorize. That's the way the exams were held, and it didn't help me at all. The way to do it is to think critically. You memorize a few things, you need that, but based on your fundamental understanding, you can extrapolate. And that's the way every student should work. Here is the surface area is about 7% of the Earth. The volume is about 2% of the Earth. The mass of the moon is about 1% of the Earth. The mean density, this is important, remember that. It's about 0.6 of the Earth, but The Earth's mean density is about 5.5 grams and the moon is 3.3. That gives us a clue on how the moon was formed. I'll talk about that quick. The gravitational acceleration, which shows that in the moon, it's about 0.16 that of the Earth. So it's easier to escape the moon's gravity than the Earth's gravity. So if you want to really launch rockets, it's a lot cheaper on the moon because you need less fuel to break the gravity field, the gravity well, rather than on the Earth. And the escape velocity, as I said, if you want to escape the gravitation force of the Earth, the rocket must have at least 11.19 kilometers per second as its velocity. Beyond that, it will escape the Earth. On the moon, it's only 2.3 kilometers. So it's easier to escape the moon than the Earth. So I won't be surprised in the future, we create settlements in the moon, but then we also start launching from the moon to other places because it'll be a lot cheaper. I just want to give you a quick idea about the moon's composition without going too much into details. But it is a very thin crust, about 60 kilometers. It has a mantle or the lithosphere like the Earth. And also there's a core, not as dense as the Earth. There might be a partially molten core. We're not very sure about that. So if you look at the moon, even with the naked eye, you can see two really distinct features. One are called the highlands, which are the cratered areas, and others is called the maria, which is Latin for the word sea. The marias are less heavily cratered, so the surface is younger compared to the rest, which is heavily cratered. These are some of the surface features on the moon. We have the craters from bombardment. We have the rays. These are called ray craters, where we have this ejector which has been ejected out and it forms rays. And you can see it better during a full moon than other phases of the moon. This rise varies from old lava depressions. These are important because in the future, if you want to land on the moon, right now we're all planning to land near the South Pole, and I'll come to that soon. But if we have these lava tubes, then we can have settlements inside those lava tubes because those lava tubes will protect us from the radiation. The moon has almost no atmosphere. It does have a very, very thin atmosphere, but it does not protect us from the radiation. So that's important. Let's see. This very quick animation will show you why the crust is lighter in color, while the maria is darker in color. So this shows you an animation. It shows when the moon was formed, it was molten lava, and it's cooled down and solidified. But because when it was molten, the lighter elements came to the top, the heavier elements sank. The lighter elements were like silica, carbon, magnesium. So it's light in color. But in the beginning, there was so much bombardment of the moon from meteorites that it cracked the surface, and lava from inside, from the magma from inside, came up, seeped out, cooled down, and formed what we call the seas. So now you see it's on the surface is lighter in color, but from the maria it's darker in color because deep down in the magma we had more of iron and other elements, while on the surface we had more of the silicates and calcium and so on. So that gives a difference in the colors of the moon. One thing also that we really need to understand is what we call the regolith, which is the loose soil on the moon. On the left is actually a picture, a real regolith collected from the Apollo mission, but it's a loose surface deposit covering solid rock. It's a mixture of dust and broken rock. And this regolith is formed by the impact of meteorites on the moon's surface. So it's very, very fine. It's finer than sand. So when we do experiments and when we do this rovers going on this simulate, lunar surface simulate, you have to be very careful because it's so fine that you can go through your nose, you can enter your lungs. So this is going to be an issue when we go to the moon, when we land on the moon. This lunar dust or the lunar regolith is very dangerous. We have to be very careful of that. The lunar regolith, as I said, contains all these minerals like silicon, aluminum, titanium, little of iron, a lot of oxygen and silica. In fact, 45% of the rocks on the surface are made of oxygen and with some silicates. Look at this. This is supposed to be a white spacesuit. But when James Irwin landed on the moon and walked on the moon, look at how the dust clung onto the spacesuit, making it grayish in color. And that's dangerous because this dust can actually affect instruments. And if it enters the body, it is dangerous. It'll kill you, basically. Very quickly, I'm going to tell you how a moon is formed. And this is the beauty of science. It shows how we try to come up with ideas, compare with observations. If it doesn't work, throw it out, come up with a new idea. So, excuse me, any theory that explains the existence of the moon should actually address three features. One is the moon has a very low density, which means it does not have a big iron core that the Earth does. We need to explain that. We also know the moon rocks have very few volatile substances like water compared to the Earth. Why is that the case? So any theory should explain that. And third, we know that the abundance of oxygen isotopes on the Earth and the moon are the same, which means that the Earth and moon were formed almost the same distance from the sun. So any hypothesis we come up with should actually explain these, at least these main three features. So yeah, I start with the first one. Sorry. And it's called capture. What this says is that the moon was formed far away from the Earth, and as it came close to the Earth, it was captured by the Earth's gravitational field. The problem that the scientists have with this hypothesis is that it has to be really precise that it came very close to the Earth at the right time to have been captured by the Earth. The probability is very low. Also, this capture theory does not explain why there are less volatile substances like water on the moon compared to the Earth. So we had to ignore this hypothesis. The next was fast rotation. They thought that in the past, the Earth spun very fast. And as it spun very fast, a part of it was thrown away from the Earth when it was molten, actually, and it formed the moon. And some people thought that the Pacific Ocean was the location where this moon was ejected out. But again, it does not explain, if that was the case, then the density of the moon and the Earth would have been the same. It's not the same, it's different. It also does not explain why there's no volatile substance on the moon compared to the Earth. So we had to get rid of this hypothesis. Next was something called co-accretion, and that is that the Earth and the moon were formed from this huge ball of gas and dust which formed the planets, and they were formed together. Again, if the Earth and the moon were formed from the same dust and rocks very close to us, why is the density of the moon less than that of the Earth? It shouldn't be the case. It should be very similar. It also does not explain the extra baking. Why was the moon baked more? Because as a result of it, which lost some of the water molecules. Finally, we come with something called the collision hypothesis, where it says a huge object called Theia, about 1/3 the size of the Earth, hit and impacted the Earth, gave it a glancing blow, and the mantle of the Earth, the material from the mantle was ejected out. It went in orbit around the Earth, solidified, came together, and formed the moon. Here's an animation which shows, here's a glancing blow, and then from the material from the mantle, actually from the moon. And that explains why the ingredients of the surface of the moon is very similar to the mantle of the Earth, because it was formed from the mantle of the Earth itself. The impact collision is that caused that extra baking, which allowed the water molecules to go away. And it also explains, because it came from the mantle and not from the core, the moon's core is not as dense as the Earth's core. So we are very happy with this hypothesis. There's almost a theory right now, unless we come up with a better explanation. So I think this is the way that the moon was formed. I just found this video just about 2 minutes, and it gives you an idea of the evolution of the moon in about 2 minutes. It's an animation. So it shows, we go back 4 billion years ago. So this is the moon, a molten lava actually, when it was forming. It was over 4.5 billion years ago. And so it's cooling to form from the moon. And here's you have called the Aitken Basin on the south pole of the moon. A huge impact created that basin. Of course, there's a lot of cinematic license in this animation. You won't hear the sound of the meteorites hitting. This is just to give some dramatic effect. But space is vacuum, sound does not travel through vacuum. But this is the bombardment stage about a few billion years ago. And this is how the Maria was forming, So when you have this crater, this bombardment of meteorites, the magma flew out and it came to the surface and cooled down, solidified. So about 3.8 billion years ago. So the Marias that you see around with the naked eye was formed about 3.5 billion years ago. This is what we call the dark patches on the moon. They're kind of younger compared to the highlands, which is high equator. This is so these are all the Marias on the moon. And then there was a lot of cratering after that, forming all the craters that you see on the moon. Again, ignore the sound, just to give dramatic effect. Kanyapan, I'll answer your question in the end, okay? So this is what the moon looks like now. I just want to show you a quick evolution of the moon. Let me go ahead. So this is a very quick, 4 or 5 slides on search for water on the moon. Because if you want to settle on the moon, if you're in a place where there is water, in whatever form, then it's easier for us to make settlements. So I'm going to start with this. This is actually a crater called Buladas. I'm not pronouncing it right, but look at this crater out here. It's within a Maria. But what they found at the center of the crater is hydroxide molecules. Hydroxide is nothing, one hydrogen atom and one oxygen atom. It's like a relative of water. Water is 2 hydrogen and one oxygen. So they found these hydroxyl molecules on the center of this crater, which is a lot more than all the surrounding surface. And what they think was, when a meteorite hit the Maria and formed the crater, magma from inside came up, and this magma minerals was coated with these hydroxide molecules. So when it came up to the surface, you see more hydroxyl molecules on the center of the crater than surrounding. So this is one evidence there could be some kind of, when I say water, I don't mean lakes of water or even pools of water. I'm talking about water molecules or hydroxide molecules. We think there is beneath this loose layer of soil that we call the regolith. And of course, the NASA, the ISRO mission, Chandrayaan mission, carried a NASA instrument called M3, and it found signature of water near the North Pole and the South Pole. This is a reflection of infrared radiation. And from that, we figured out the blue color is where the water is in the North Pole and the South Pole. So we think there is a lot of water in the form of ice, and I'll talk about it later, in the North and South Pole. So obviously, every country is trying to land near the South Pole of the moon because they think there's more water in the form of ice. Recently, NASA had an observatory called SOFIA. It's an infrared observatory. It's actually a rocket on a Boeing 747, and it goes orbits the Earth, goes around the Earth, but it has infrared radiation instruments. And what it did was it took some measurements of a crater called Clavius crater. Now, in the past, I said we detected hydroxide molecule, one hydrogen and one oxygen, because it's easier to detect that. To detect water molecules, we need very fine, precise instrument. Now, SOFIA have that instrument. And for the first time, we were able to actually detect water molecules and not hydroxide in this crater. But it was very, very small, 100 to 412 parts per million. Because if you take 1 cubic meter of soil across the lunar surface, you might get a 12-ounce bottle of water. This is negligible. In fact, the Sahara Desert is 100 times more, you can call the word wetter, than the moon. So, we talk about finding water molecules on the moon. It doesn't mean that there's water on the moon in the form of lakes or pools or anything, but it's water molecules. But why is it important? Because we can take the soil, which has these water molecules, we can heat it up, we can generate oxygen from the water molecules, we can also extract water from them. So there's a reason why we're excited that there are water molecules on the soil, because we can use it to generate some more water or oxygen. But on the south pole of the moon, you see the moon's axis is tilted by about less than 5 degrees. So on the south pole of the moon, when you have craters, sunlight barely reaches the floor of the crater. So there's one crater called the Shackleton crater. It's after the explorer which went to the south pole of the Earth, Antarctica. It's named after him. But in the on the crater floor, they have seen evidence of ice. Okay, and now this ice would have come from comets which kind of crashed into the moon in the past, but because it was in the floor of the crater and because sunlight barely reached, ice could exist. And we think there is ice there because we see a lot of indirect evidence of that. And that's why most countries want to go to the South Pole, because they want to be near these craters which have this ice. They can use the ice to get water and oxygen. In fact, in my institute, I have a project where we are working on rovers, mini rovers and one large rover. And the idea is that the large rover will go to the rim of the crater, and the mini rovers will go down, collect all the ice and bring it back to the main rover, and then bring it back to a base. So we have students, college students, and even high school students working on the software, on the mechanics of the rover. And anyone, if you're interested, I can give you a link where you can download and 3D print the rover, and you can download the software all for free. Here are some examples of water found on the South Pole, on the North Pole. Here's the South Pole, and here's the water places where we think there's water in the form of ice. So as I said, the water could have come from comets. Comets are nothing but dirty ice. And they would have crashed onto the moon craters in the South Pole, no sunlight reaching, still there. Or the other way is that it's from the interaction of the solar wind. The solar wind is the energetic particles being emitted by the sun. It's actually nothing but what you call hydrogen ion. Hydrogen is one, it has one proton and one electron. So when the electron is stripped away because of the high heat, you have this hydrogen ion, which is just a proton. They are traveling at the speed of light. When they come and reach the moon, the moon's rock, as I said, has about 45% of oxygen and silicates. So this hydrogen atom, proton, is going at a very high speed. It hits these molecules, and it breaks the bond between the oxygen and the hydrogen and the water molecule. And when we do that, when you have loose hydrogen, when you have loose oxygen, there's chances of the hydrogen, oxygen, 2 hydrogen and 1 oxygen meeting together to form water molecules. So that's one way that there could be water molecules on the moon, is because of the interaction of the solar wind with the moon. We also have seen that meteorites during the meteor shower can actually has resulted in water being ejected, water molecules being ejected from the moon's surface. So here's an animation, here's the lunar surface. It's mostly covered with this loose dust soil, which we call regolith. But when there's meteorites, so during a meteor shower, we have a lot of meteorites hitting the moon. So when they hit the moon, they penetrate this loose soil, which is the dry regolith, and you go below that, you what is called the hydrated soil, which has some water molecules or hydroxide molecules. And when it does that, it releases those molecules, and these water molecules go to space, and they were detected by a spacecraft called LADEE, which was orbiting the moon. And it found out that the peak of this water molecules detected was in sync with meteor showers. So we think that there is water on the moon. I want to show you this slide because this is going to be interesting politically in the future. So as you go to the south pole of the moon, as I said, the moon's axis is barely tilted. So there are a lot of areas where sunlight does not reach, like in the crater areas. But if you want to do real work on the moon, we need sunlight to generate solar energy because we don't have nuclear power on the moon or electricity. So to do that, we need to go to places where we call this peak of eternal lights. These are higher areas where you can get more sunlight. And these are going to be interesting because one country can say, look, I've taken over this peak out here, you cannot come near it. Or one country can say, I'm here, you cannot come near it. This could result in problems in the future. So it's so important that right now, all countries come together and come up with a treaty to discuss all these things. So I spent a lot of time on the moon. To quickly go to how we are going to go to the moon, at least from the point of NASA's point of view. But we are going to the moon to prepare for Mars. Eventually, we would like to go to Mars because we have so many evidence that there might be water on Mars underneath the surface and so on. So we want to prepare to go to Mars. The problem is that to go to the moon, we can reach it in a few hours, in a couple of days. If something goes wrong on the moon, we can have rescue missions. To go to Mars, it will take at least minimum of 6 months just to go there. So if something happens on the moon, if you're not ready with the technology, those astronauts will be stranded and we can't do anything with them. Or we have to wait for a long time to send help. So we want to test all our technology on the moon, then go to Mars. So we are preparing for Mars. And how are you going to go there? So we're going to have new rocket launch towers. It's already been built. We have what is a new rocket called SLS. I'll talk about that quickly. We have what is called Orion, which is going to carry the astronauts. The Orion is actually right over here. That's the spacecraft carrying astronauts. We're going to have a small space station orbiting the moon, and rockets from here, satellites will dock with the space station, and then from the space station we'll land onto the moon with the help of lunar landers. And of course, we have to have new generation of spacesuits because the old spacesuits are not good for exploration. So these are, in a nutshell, is how we are going to go. So how are we going to get there? What kind of rocket are we using? So NASA has built this rocket called the Space Launch System. It is controversial, it's expensive, but that's all we have right now. But right now, if everything goes fine, it'll be the most powerful rocket in the world. And this gives you an idea of how tall the rocket is compared to the space shuttle. I'll talk to you more about that in a second. The rocket booster. The rocket booster is nothing but these two white things in the side. They're made up of solid fuel, and they provide most of the thrust required to escape the gravity well of the Earth. That gives you 75% of the thrust. And they're mostly, it's solid fuel. So once you start igniting, once you ignite it, you cannot stop it. It'll continue burning. And there are 5 segments in this rocket booster. Look how tall they are. They're about 17 stories high. And each booster can generate more thrust and power than 14 4-engine jumbo jets. Think about it. Each of this booster is more powerful than the thrust generated by 14 of these jumbo jets. For people who like numbers, as I said, I don't remember numbers, but here you go. Length is 170 feet. It's 12 feet in diameter. Its weighs about 1.6 million pounds, but it operates for about 2 minutes. And that's what is required to provide the thrust to escape the Earth's gravitational field. And then we have the engines. There are 4 engines in the bottom. That provides the rest of the thrust, 25%. I want to talk to you briefly about this because we had a problem during one of the launch with one of these engines. But these engines will run for about 8 minutes. But look at the operating temperature range from minus 400 degrees to 6,000 degrees Fahrenheit. Look at the way it ranges. It can operate from minus 400 to plus 6,000. It's an amazing feat of engineering. My hats off to engineers and material science scientists and so on. But here is a quick infographic on the RS-25 engine. It has basically 4 powerful, what you call turbo pumps. And what it does is it creates the pressure to flow liquid hydrogen, liquid oxygen, which is the fuel, to this combustion chamber, which mixes the fuel. And then this is the nozzle that increases the velocity of the fuel and directs it. And then as it comes out from the rocket engine, it's about 13 times the speed of sound. So if that is the speed at which this exhaust fuel is coming out, at that speed, you can go from one end of the United States, from New York to Los Angeles in about 15 minutes. And look at these operating temperatures, minus 400 degrees Fahrenheit to 6,000. It's amazing. It's about the size of a medium car that we have, maybe ambassador car that we had in the past. But it is an amazing piece of machinery. I like to show this video because it explains the whole space launch system hardware without me talking much about it. So this video will show you different parts of the rocket. It is very complicated. I want you to understand the different parts. So we have the Orion spacecraft, which is on the top, and this is a space launch system. What did I do? So this is what is called the launch abort system. If something goes wrong, this is a small rocket which can pull the Orion capsule away from the rocket. This is the Orion capsule. This is called the inner stage. Adapter between the 2 stages. There's again a skirt between connecting 2 stages. This is the liquid oxygen tank. Look how big it is. That's one of the fuel. And then you have the liquid, this is the intertank between the liquid oxygen and liquid hydrogen. There's a liquid oxygen tank. Sorry, liquid hydrogen tank. Again, gives you an idea of how large it is. Here's the engine section. So here are the 4 RS-25 engines. These were used on the space shuttle. And here are the rocket boosters. So these are all the parts of the rocket. Everything has to be tested. Everything has to be working perfectly for a launch to take place. And NASA takes its tests very seriously. As it shows in this video, this is a video showing how the tank, the liquid hydrogen tank and so on, can resist the vibration of a launch. So they test it to an extreme. So here they're testing the tank. We have humans on this rocket, so we really have to keep on testing and testing when everything is done. And these are called structural tests to test the integrity of the structure. So there you go. This is in Huntsville in Alabama at Marshall Space Flight Center. And they actually shake this the tank to mimic the vibration of the rocket as the rocket launches. And they push it until it fails because they want to see how far they can go. But look what happens when they try to put more pressure on it. It actually pops out. There you go. Now, they have gone way beyond what this tank will experience during the launch. But they want to be sure that everything works fine. I wanted to show it to you because testing is very, very important. So what happened is once this rocket was created, before I talk about the other parts, we had to do some wet dress rehearsal, which means that we have to see what will happen when we fuel the tank. So liquid hydrogen, liquid oxygen are not in the rocket all the time. They have to be fueled once they come to the launch pad. So what is called a wet dress rehearsal is you fill up the tanks with liquid oxygen and liquid hydrogen. Look at the temperatures. And that is what caused problems with liquid hydrogen leaks later on. But this was just what called a wet dress rehearsal. They didn't actually launch the rocket. They went all the way to 10 seconds to countdown, and they stopped. So I live in a town called Titusville, which is just across Kennedy Space Center. And so I went to the beach near Titusville and took some pictures of the rocket. This is from my hometown, and this is the rocket beyond in what is called the Indian River. Here's a picture of the two launch pads taken from space. This is the NASA launch pad. This is Spacex launch pad. This is the Atlantic Ocean, and Titusville is over here. Here's a picture of the vehicle assembly building, which houses the rocket before it goes to the launch pad. And here's a picture of the rocket, NASA rocket on the launch pad. Here's the SpaceX rocket on the other launch pad. So when they did the dress rehearsal, there was this hydrogen leak. They found the hydrogen leak, and this hydrogen leaks happened a lot during the shuttle mission. And in a slide or two, I'll explain why the reason is. The other thing was that when there was in the launch pad, you see these long towers. These are lightning rods. They attract lightning. And in fact, during the time it was there, it attracted bolts of lightning, as you can see here and here. If we didn't have those launch pads, because the rocket is stalled, the lightning bolt might have hit the rocket itself. So that's a problem that we have to face, especially if there are thunderstorms. That's why we have these lightning towers next to it. Before I go and talk about the actual Artemis launch, which was supposed to have taken place about a month ago, quickly, we have this, what is called the Orion multipurpose crew vehicle, which will house the astronauts. So this is the crew module, this is the launch abort system, and this is the European Space Agency's module, which provides the energy and the food and everything. I won't go into that in detail, but I want to show you what is inside Orion. It's like an X-ray inside the Orion system. It's built by Lockheed Martin. So it can take 4 astronauts. It's a little bigger than the Apollo crew capsule. And of course, the displays are digital like iPads. And there's a radiation shelter because as you go beyond the Earth's atmosphere, there's a lot of radiation. So the shelter shields them from the radiation. This is the environmental control and life support system, keeping it the right oxygen level, the right temperature, the right pressure throughout the trip to the moon. There's an exercise machine also and a water dispenser in that capsule itself. And of course, there is a toilet. The toilet is very expensive. It could be $1 million because, it is like in a zero gravity environment. So that's what Orion Right now, we have digital controllers as opposed to analog controllers. I'll skip this because how much time do you have, Chintamani? I'll just quickly skip some slides because I can't talk much about them. If you tell me how much time I have, Chintamani, I can just skip some slides.
5-10 minutes more.
Okay. So I'll be done by then. So as I said, we're going to have to build this small space station around the moon, but we haven't yet got the funding for all of it. So I won't talk much about it. But the idea is to have an outpost in lunar orbit that will be a staging point for the human and robotic exploration. So what NASA plans to do is first have Artemis One, which was supposed to have launched a month ago. And that is just to go to the moon, orbit the moon, and come back. Artemis 2 will send humans, not land on the moon, but come back, go orbit and come back. And then Artemis 3 will actually land astronauts on the moon. And we want that to be one woman and one man who will be astronauts landing on the moon. That's a plan for the next. It won't be by 2024. I think it'll be 2025 or 2026. So the Gateway is a platform. It's like the space station, have different modules. And the idea is that we'll have a rocket from the Earth, which will go to this space station, dock. And from there, there'll be a lander. I think this one is a lander. They'll go to the space station, they'll go to the lander and use the lander to land on the moon. Instead of going directly to land on the moon because it is more expensive, you have to brake, you have to slow down, and that spends more fuel. So better way is to go to the space station, dock, transfer to the lander, and go down. That's the plan of the Gateway, but we have just started building it. And the Gateway will have this, what is called a halo orbit. The Apollo orbit was an equatorial orbit around the equator. This is going to be a halo orbit for a number of reasons. For surface operations, for communications, is better for science and very easy access as compared to other orbits that we can do. But so it will be in a halo orbit. And that's an idea of the Gateway. We have a number of countries taking part in the construction of the Gateway. That's a plan. Here is the launch control system for Artemis One. This is, I think it's at the Johnson Space Flight Center. I want to talk very quickly about this. NASA actually provided 3 companies to send payloads to the moon. One of them is Intuitive Machines. I'm talking about that because I have a group of students in a university in Florida who are working on have worked on a payload that will fly with this spacecraft built by Intuitive Machine, hopefully at the end of this year. And what it does is that these students, these are actually undergrad students, they're built in this big box, like a cube-size big box. This big box that you see out here has cameras on 5 sides. And the idea is that this box will be in this Nova lander by Intuitive Machines. And what it'll do is, as the lander is landing onto the moon, unmanned, uncrewed, there's no one there, before it lands on the moon on a controlled descent, they're going to drop this box. It'll free fall onto the moon. It'll fall onto the moon before the lander lands on the moon. And because there are cameras on all 5 sides, it doesn't matter how it lands. It'll take a video and it will send it back to the Earth. Again, I tell you, these are all done by students. And I supported the test on a Blue Origin launch to see that the vibration and all the other stuff during the launch does not affect the payload. And it did affect. Soldering came loose because they're going to drop this whole box onto the lunar surface from a height. But these are my students really taking part. And that's where they're going to land onto the moon. NASA did send out a request for proposal for companies to come up with ideas to land on the moon. See, NASA is not doing everything by itself. They're outsourcing to other places. And so they're outsourcing to other companies. And there were 3 companies which sent in proposals. One was Blue Origin, one was Dynetics, and one was SpaceX. NASA chose SpaceX to be the human lander to land onto the moon. This is a SpaceX Starship. is being built in Texas. It's a huge, huge spacecraft. Here gives an idea of how big the Starship is. Recently, just a week ago, NASA identified regions where we would like to land in the South Pole. Each of these blue areas are about 12 kilometers across. And there'll be numerous landing sites. This is the South Pole. This is the Shackleton crater I talked about. And there was various reasons why they wanted to choose these areas. Close to the South Pole, gentle slope for landing and moonwalks. You don't want a steep slope. Constant view to the Earth for communications. You cannot disrupt communication. Continuous sunlight, landing accuracy, data resolution, and so on. So therefore, looking into all this consideration, they come up with all those different areas that they would like to land in a few years. Finally, I talk about spacesuits. The spacesuits that we used was very good for extravehicular activity during spacewalks, but they're not good for exploration. To give you an idea, look at this is one of the moonwalks, Apollo 15. Look how he tripped and fell onto the moon. If it scratches the surface, the spacesuit, then that person is dead because there's oxygen inside. Which if it tears the spacesuit, oxygen will leak out, the dust will go in. So be very careful that when you're doing build the spacesuit, that they are flexible enough to do the walk on the moon and to explore. So NASA came up with two different kind of spacesuits. One is for the extravehicular mobility, and one is for survival when you're in the spacecraft itself. This quick video will show you how. And these are again being built. This is not yet done. But it shows you how the spacecraft have different parts to them. This is just for launch and re-entry. You're inside the spacecraft. This is not to be on the surface. It's orange in color because in case you land on the ocean, the stuff is easy to select to find the red suit. This is the one that we use to land on the moon or Mars. It's modular. It can fit different sizes. So you see, you can bend easily now. And you can remove different parts of the spacesuit to fit different folks. Whether a man or a woman, tall, short, you can do that. And then we evolve it from Mars. So and this is Artemis One mission to the moon. I don't have time to go through it, but basically, Artemis One mission is uncrewed. It'll go to the moon, make 2 orbits on the moon, and come back to the Earth and splash in the Pacific Ocean. So the first attempt we had was on August 29th. And there was a series of glitches during countdown, including a hydrogen leak. And also they found that this is this inner skirt between the Orion and the fuel tank. They thought that they had a crack in the structural crack here. But actually what it is that this is covered by foam to insulate the inner part because it's so cold outside. They thought it was a crack, a structural crack, but actually it was a crack in the foam itself, and moisture went into the crack and it seeped out, and they thought that it was a crack on the structure itself. That was not the case. But there was a problem with liquid hydrogen leak. It was leaking, so they had to stop it. They tried to figure it out, they couldn't do it. They thought there was a problem with the seal. The other problem was that, I remember I told you the engines, they have a range from -400 to +6,000, but you cannot shock the engine by pouring in cold fuel at one time. So you have to slowly temper it. So what they do is what's called bleeding, hydrogen bleeding. They allow some of the liquid hydrogen at that -400 degrees Fahrenheit to come down to the engine and then slowly cool it. But out of the 4 engines, one of them had the wrong temperature. It was not cooling down properly. So they had to stop it. So what we're doing now is to stop that. Instead of bleeding it very fast, we're slowly allowing hydrogen fuel to go through and temper the engine before the whole hydrogen fuel goes to the engine itself. So that's why they had to stop it. The second attempt was again on September 3. Again, they had a problem with the hydrogen leak. And here's the problem with hydrogen. The hydrogen molecule, you know, the hydrogen is the smallest atom in the universe. The hydrogen molecule is just 2 hydrogen. It's very, very small. And it's very cold. So when everything is cold, you know, the liquid hydrogen tank is very cold, the inner tank is very cold. When it's very cold, it shrinks. If there are any cracks, this hydrogen atom can enter those cracks. And that's why we have those leaks. That's why hydrogen, we have these hydrogen leaks. We had in the space shuttle, we have it right now. This is the quick video, not a video, but so it was scrubbed because there was a hydrogen leak from this pipe, which is actually feeding hydrogen. As I said, liquid hydrogen is a very low temperature. It's very, very small. But because it's so cold, you have to be very careful that everything is insulated. And why we use liquid hydrogen? Because there's more energy per gram than methane, propane. And when it combined with liquid oxygen, we have a great fuel that is very, very energetic. But again, as I said, liquid hydrogen goes to a temperature of -400, and that causes a problem because it's so cold. If they are not insulated enough, if the tanks are not insulated, if the pipes are not insulated, if there are cracks in it, then the hydrogen, because it's so small, can go and enter these cracks, and that's why we have these leaks. So what SpaceX is doing is, in the future, they're going to use methane instead of liquid hydrogen. They use liquid methane, which is a larger molecule, but is not as efficient as hydrogen. So that's what SpaceX is going to use for Starship, use liquid methane. Again, liquid methane is not as efficient as liquid hydrogen, but it won't cause us problems of hydrogen leak. So you see how liquid methane is a larger molecule compared to hydrogen, but its energy that it can produce per unit mass is a lot lower than hydrogen, but its liquid form is -260. So you can ask, why is NASA using liquid hydrogen? For one thing, in 2010, when Congress came up with the idea of this rocket, they said that NASA should be using existing infrastructure. So they were trying to use the existing propeller system, the existing rockets. So we are kind of stuck with liquid hydrogen, but it's very efficient, it's a lot cheaper. But I think in the future, as we progress, we'll move from hydrogen to liquid methane. So those were one of the reasons why it was scrubbed in September 3. So the next one was on September 27th. And guess what happened? Ian, a hurricane. Look how big the hurricane is. It covered the whole state. This is the eye of the hurricane, okay? This is Kennedy Space Center. I'm talking right from here across Kennedy Space Center in Titusville. Look at the track. Here's the track. It came from down south near Fort Myers, went across the state, okay? Went across Kennedy and went up north. I won't talk about this of the destruction. It's awful. But look at this path. What happened? Look at the path of the storm. As it came towards Kennedy, it became a storm. It was less powerful. But look at the path. It took it between the 2 launch pads. That's where the storm went. Luckily, the rocket was brought back. Look at the speeds. 1 knot is, to convert from 1 knot to miles per hour, you just add 10% to it. But as you went higher up, it was more, the winds more powerful than on the ground. And the rocket is about 200, 300 feet high. So if the rocket was on the launch pad, on the tower, it would have faced about 80 miles per hour winds. So luckily, NASA was able to bring back the rockets. You have this transport crawler waiting for the last 3 days near the rocket. When they found that the hurricane will come towards Kennedy, this crawler transporter went up. This is a mobile tower. It's on top of that, and they brought it back to the vehicle assembly building. The vehicle assembly building, believe it or not, is about 50 to 60 stories high. It doesn't look that way. It has only one floor. That's the ground floor. There are no other floors. It's one huge building. Sometimes there have been clouds on the top of the building. It's so big. But that's where they keep the rocket. Hopefully, we can have the launch soon. Unfortunately, there's a SpaceX launch going to the space station on October 5th. So the next NASA launch might be the end of this month. We're not very sure. So, I don't have time to talk about the moon dust. Just to tell you, that's awful. There's a lot of problems. I think I gave you a lot of information, and I want to stop right here to answer questions that you may have.
Okay.
I know there are a couple of
Thank
people
you
who had some questions. Gentlemen, if you have time, I can answer a few questions.
Yes. Just give me a moment. Thank you very much, sir, for such a beautiful talk, because you took us all the way to the origins of moon, and then coming to the whole technological aspects of Artemis and beyond Artemis and the whole concept, and that exactly fits to the this World Space Week's concept of space and sustainability. So here we are at the question and answer session. So if there are any questions from students, they can unmute themselves and they can directly ask to Dr. Jaydeep Mukherjee. Or if you're having some mic issues, you can as well type your questions in the chat box.
And when you ask a question, tell me whether you're a school student or a college student, just general public. It gives me an idea.
Okay.
And there are two participants who have raised hands, actually. Maybe you can.
Okay. Mr. Subir Kumar Bandopadhyay. Okay. Go ahead, sir. You can.
Hello, sir. Am I audible?
Yes.
Yeah, go ahead.
Yes.
Audible. Please go ahead.
Thank you, sir. Throughout the program, I was not audible to you because whatever your value speech, I feel it. That what the speech you have delivered, that is wonderful, sir. Sir, one question I like to ask you, that you have mentioned that the surface material of the moon is volatile, and but basically it is silicate. So silicate, how it becomes?
No, it does not have any volatile elements. It does not have it.
Something like magnetic effect, whatever we are generally doing in our Earth plus the magnetic field north-south direction. Something it has been happened. Am I true, sir?
I'm sorry, you're cutting out. If you can type in your question, or if you can email me a question, I can answer you back. But I couldn't hear your whole question.
Yeah. So maybe we can go with the next question. Kamya, can you unmute?
Probably it's morning, guys. So good morning, Jaydeep, sir. I'm Kamya and I'm in 11th grade right now.
Okay.
Probably this question is a bit off topic, but I'd like to ask you this. That the prevalent traffic in the space industry, why is it inclined more of towards the political aspect and, defense of the country? Because why aren't we as a whole a complete one strand as a humanity researching and exploring the space industry? Why is there exists this competition?
Right. So it's a very good question, but you're young. That's why you can ask this question. As you grow older, you'll find out human nature is such that at your age, when I was your age, even right now, collaboration is an important thing. But why politics come? It's because it's mostly funded by the government right now. When it's funded by the government has to take into effect what the country feels like, what it wants to do, for the defense of the country because they're using taxpayers' money. But what is the good thing that I'm seeing in India and of course in the US, it is private companies, So like Bezos and SpaceX and another one. So these are individuals. They may not have these political issues. So even in India, I know there are a number of companies coming up. So what was your name? I forgot your name. But I think you're on the right age. In the next 2 or 3 years, you're going to find more support coming from this industry and from small companies other than from the government. You do need the government. We need the government to explore, to do things. But it's going to change. It is slowly changing, but it's human nature. We are going to, first figure out what's best for our country in terms from the government point of view. From a civilian point of view, as you said, let's all work together. But look at the Chinese, they're doing things on their own. Look at the Russians, they're refusing to collaborate. Yeah, so the European Space Agency wants to collaborate, US wants to collaborate, India wants to collaborate. But then again, as we go to the past, the US had problems with India with the cryogenic fuel. So politics will play a role. Unfortunately, that is not going to change. We have to take that into account. But the good news is that a lot of private companies are coming up. And maybe you, as you grow up, as you go to college, you come up with a way of coming up with your own company and being involved in the space missions. I have seen a lot of students, my students here in Florida universities, they have started their own companies and they're contributing to this huge space changes that we're going to see over the next 10, 15 years. Good question. It's not off topic at all. It's very important.
Thank you, sir. We have Mr. Srinivas Lakshman. Are you there?
Yeah,
he
I'm here.
has a question.
Hi, Jaydeep. This is Srinivas.
Please go ahead, sir.
A very excellent presentation on the Artemis mission. What I do want to know is, how would you compare NASA's SLS with SpaceX's Starship?
I have to be careful how I answer this question. I think eventually it'll be the Starship that we'll be using. So NASA LS's rocket is very powerful, but it's as first speaker said, I forget her name, I'm awful with names, but it's politically motivated. The reason NASA stuck with SLS is because, states like Florida, Alabama, Texas, which has these NASA centers, the senators of those states, they wanted to build this rocket because it will provide jobs in their states. So this rocket has become very, very expensive. There are a lot of criticism on these rockets, but NASA is also supporting. So SpaceX wouldn't have been doing so many things if it wasn't for the fact that it was subsidized by NASA itself. NASA has contributed a lot of money. So personally, I think it'll be Starship is going to be the rocket of the future.
Wow.
I think because SLS is going to be more powerful, but it's going to be a lot more expensive, a lot more. So we can have very fewer launches with SLS compared to Starship.
Okay.
Thank you, Jaydeep.
Okay.
Thank you, sir. We move ahead with maybe we'll have 1 or 2 maximum questions. Amanpreet Kaur, Dhiman, can you unmute yourself? Yeah.
Hello, sir.
Hello.
I just wanted to ask that how, I'm in 10th grade right now, and I want to ask you how I can be an astronaut, in NASA.
Well,
yeah.
So, you have a better chance being an astronaut with ISRO than with NASA because for NASA, you have to be a US citizen first. But here's the best part is that there are so many private companies coming up that you can be an astronaut with them without even trying to be a citizen of that country. So right now you're very young, but not too young to start thinking about this. But there are ways you can do. Well, one thing is, you can be when we say astronaut right now, in the past, astronauts are either people in the military, Air Force, and so on. Even Rakesh Sharma was, I think he was in the Air Force. But now we're going to have a lot of civilian astronauts. And these astronauts can either be scientists, engineers, poets, and so on. So there is no straightforward way. I can't tell you this is the way that you can be an astronaut. But all I can say is that if you want to be an astronaut, you follow your ideas, you follow what you want to do, and there will be a way. Because it'll be a lot different 10 years from now when you're past college. That being an astronaut will be very simple through space companies. So you're welcome to keep in touch with me. You can get my email from Jinkamani, especially the students. I can reply back to you by emails, but there is no direct way that you can be an astronaut. In the US, there is a way. For a US citizen, you have to take some tests, take some exams, you're selected and so on. I'm sure ISRO is going to have the same thing now with their human program. But I'm telling you, you'll have a better chance being a civilian astronaut in any of these countries.
Thank you, sir.
But keep up that dream, okay? Don't give up on it. There will be a way.
Maybe, sir, maybe a last question. Let me just see who is raising the hand. Anushka, can you unmute yourself? Anushka, are you there?
Ask Rajiv.
So, sir, I had a doubt. I am Anushka. I had a doubt that first at starting you were telling about why do we explore. In that you were telling that we can turn the direction of the asteroid that is coming towards the Earth. But sir, how is that possible? I was little confused in that.
Okay. So look what's happening. When anything orbits another object is actually gravity. Okay. So for example, suppose you take the moon orbiting the Earth. It's following a certain path. If there is any way that we can do something by moving the position of that moon by a very small amount, it will change its orbit. Okay. So the moon and the Earth is a bad example because the moon is very large. But if you take a rock, an asteroid, and if it is very far away from us, not very close to us, we cannot do this if the asteroid is very close, but it is very far away. If you can crash something onto it, it can change its position a bit. But by changing its position a bit, its orbit changes. It won't follow its same path around the Earth. You take a slightly different. And if you can deflect it by a small amount, and if it is very far away, then this orbit will make it miss the Earth as it goes around. That's the idea. That is one of the ideas, is to deflect the asteroid. If we can find it very far away from us, if it is not huge. And that was a test that they did, and we'll take a couple of months to find out whether the orbit of that small asteroid has changed as a result of the deflection. But that's what it is. It just moves an asteroid a very small amount, changes its position by a very small amount, but that might be enough to change its orbit and miss the Earth.
Maybe, sir, last question I'll ask from my side. So you, sir, spoke about lots of private missions, private companies to whom there has been a mission. The mission has been outsourced to carry out as a part of Artemis. So what are their objectives as they land on the moon, or what kind of studies they will be carrying out through such land?
Well, when NASA is outsourcing, is basically to help its own project, right? So NASA has its own vision and goals. But if you go, say, to SpaceX, right now, the only one which has plans to go to another planet is Elon Musk and with SpaceX. His idea is to go and settle on the moon and have settlements on the moon, just for that. But if you look at the small companies coming up, for them, it's go to asteroids, go and mine the asteroids. It's for profit, okay? If they want to go to the asteroids and mine the materials which bring back to the Earth, they'll be very, very expensive. They can make a lot of money out of it. So I know about 7-8 years ago, a number of these companies came up. Half of them are gone. But most of the companies, this is where the government comes in. If you really want to do pure exploration, a space company, it has to survive. So it has to have some profit orientation, you know. Unless you're a very rich person like Bezos or Elon Musk, you'll have other reasons for going to space, and that is to make some profit. But there are very few companies which has this ideological viewpoint of landing onto the moon or to Mars because they want to figure out ways to settle there. But it'll slowly change. I wish for. I mean, you see, there's so many billionaires in India. You know, why doesn't one of them come up with and try to bankroll one of these missions? And India can be a part of this private companies doing that. I wish they would. You know, you have. I think the third richest man in the world is an Indian right now. So I wish they would do that. I wish they would try, you know, for them, it may not be for the money so much, but, you know, it's going to help all these kids growing up. They can take part in this whole mission, and, you know, they can start their own companies to support this mission. They'll be more excited to be a part of the STEM workforce, which I don't think is required in India. We have enough as it is. So I don't think the private companies have these ideological goals of going elsewhere, mostly for profit, except maybe for Bezos and Elon Musk so far. And then the other guy, I forget his name, who has his inspiration mission. So there are 3 or 4 companies, people who are doing it. But if you look back in the past, you go back to the late 18th century and the early 19th century, in the US, most of the astronomical observatories were 32 out of the 36 were bankrolled by individuals or by foundations, the private sector, which did that. So I don't see why in the next few years, the private sector will play an important role in these missions to the moon or to Mars. And one of them is to figure out ways how we can settle them.
Thank you very much, sir. And thank you very much for wonderful talk. I think on the moon observation day and start of we were really fortunate to have you. I'm sure all the students, young students especially, you have inspired them. I think that's part which has been now in which has come in their mind. That will kind of self-guide those who choose their careers in future. And
Chintaman, you can give them my email address, if they, especially the students.
Yeah, in fact, that's what I have put up on chat box, that we may not be able to take up further questions because of lack of time. So please share your questions. We'll share it with Jaydeep sir, and share your email ID also, so that he can directly reply, or we can get it and share it with you.
Okay.
And we hope we'll have Jaydeep sir once again when this Artemis is launched. And maybe we'll some more information for our audience. And when he will be coming, perhaps we may see him physically there. Sure. Whenever he'll be in Mumbai, we'll try to request and bring him at maybe at Science Center or Planetarium, or at some place where we can have interaction with him.
I'll be glad to do that.
Yeah, it's really nice to listen, Dr. Jaydeep. Thank you, sir.
Thank you, sir. Just a request before we sign off. The link for receiving your e-certificates is shared in the chat box. So all those who have copy that link and get your e-certificates, and stay tuned with us. We have another Monday where Dr. Jennifer Blank, now that we have gone to the moon, she'll be taking us to the journey to the Mars and what are the updates from the Mars Perseverance mission. So see you all there, and please the Zoom links what you have received, that we can have maximum participation, and those who are not able to join on Zoom link, they can join from Facebook Live. Thank you very much.
And hope we'll put up this lecture also on our YouTube page after doing some putting it, you can say editing that. Hope we have the recording and then we'll put it. Those who have missed or want to listen again, they can see it there also. Thank you very much.
Thank you all.
Bye, everyone.
Thank you.
Bye.
Bye.
Yeah. So.